Hi, I'm Jan Beta, and today I'm going to attempt to build a Commodore 64. So as you probably know, there are a number of replica boards that are reverse engineered versions of the original Commodore 64 boards. Some of them have some added functionality, and there are ones that are available for purchase. There are some that are open source and you can just have them made yourself. And I'm in the fortunate position of having been donated, I think, nearly all the boards that are available these days, one of each, of course, not all of them that are available in the world. So there's probably going to be a number of videos of me populating Commodore 64 boards, different revisions of them, and checking out how well they work and if we can get them to work at all in the first place. This episode is going to be a special project that I had in mind for quite a while now. I'm going to try to build a Commodore 64 that uses as many newly made parts as possible. So as you know, there is a lot of replacement chips for some of the proprietary chips that the Commodore 64 used, such as the SID sound chip and such as the clock chip and the PLA. And I'm going to use several of those, as many as I can use, and basically see how far I can go and have the Commodore 64 still work. So join me on this new adventure. I hope it's going to be fun for everyone. There's going to be a lot of soldering and a lot of time-lapse shots of me soldering and swearing, probably, I don't know. But yeah, that's the project for today. Hope you enjoy. And for this particular project, I'm going to use this revision 250466 Sixtyclone board that was reverse engineered and actually provided for free to me by Rob Taylor, aka Peepo. As I pointed out a number of times, these 250466, which is the latest revision of the older style long boards for the Commodore 64, is my favorite board revision. It kind of combines the best of both worlds of the short boards, which are pretty stable because they use more modern RAM chips, and the old boards, which use more separate chips, so they are easier to troubleshoot and easier to repair in the end. This is my favorite flavor of Commodore 64 ever, so I decided to use this board for the modern C64 build that I'm going to do. As I said, I'm going to do a number of C64 builds, and want to thank everybody who donated chips and parts for this. I'm going to show some of the new parts and some of the old parts that people donated to me during this video. And I'm going to put links to everything that I'm using, or to everything I can find links for that I'm using, in the video description as usual. So you can use that as a reference in case you want to do something similar. I think this is going to be fun, at least for me. I hope it's fun to watch. I'll try to make this as entertaining as possible. Let's get into it. Let me take some seconds to thank my sponsor for this video, which is PCBWay, who are, as you probably know, a premium manufacturer of prototype PCBs with very high quality standards. Actually, I think the board that I'm using in this build was actually manufactured by PCBWay, so yeah, pristine quality. If you want to make your own boards, just design something in your preferred design software, head on over to PCBWay.com and have the PCBs manufactured. There are some festivity activities planned for December, so be sure to check the site frequently, and the link is in the video description. Here's the board, nicely laid out black replica board of the 250466 revision of the Commodore 64. Gold plated, of course, because yeah, basically Rob spared no expense. This is actually still available on his shop. This is an early revision, version 1.2 from January 2020, and he actually sent this to me shortly after he finished reverse engineering and making the boards. So thanks for that, and I'm sorry for the delay, but that's how things work in the beta lab, I guess. So this build is going to be based on this board. And Rob actually also sells parts kits which have the smaller components nicely labeled in these bags. and he provided me with some of those as well. We have the little resistor packs that are not so easy to obtain. You can, obviously, if you know the parts numbers, you can obtain them. And the capacitors and the resistors. However, I'm not going to use these because I got another pack that Gopher sells, who's actually mentioned in the credits for this board as well, Martijn, and he sent me this pack from the Run Stop Restore, which is a nice wordplay, which is kind of a more complete version of what Rob has, which also includes all the connectors and some more small parts like the ceramic capacitors. And he also provided the small logic chips and the RAM and a lot of nice round pin, turn pin sockets and the electrolytic capacitors. So I'm going to primarily use these parts for the build, and a link to the Restore is also included in the video description in case you want to buy one of these kits, which I can highly recommend. He offers kits for a number of different board revisions. So I think I'm just going to start soldering, and with projects like this, to keep track, it's always good to have like a list, like this is labeled on the package and so is Martijn's offering. There's labels for where each component goes, which is all kind of neat to have. But there's something better actually that my friend Edu Arana set up on his website. I'm going to show you. Enter the C64 parts locator or PCB locator on arananet.net, which is also going to be linked in the description. Edu has the assembly 250466 all laid out here, and we have a little drop-down menu where we can choose the components and we can see where they actually go. So we have these little green lights, we can also have them blink. We can see where the ceramic disc capacitors go that we chose in the menu. And this is going to be really useful for this build. Thanks Edu for providing the world with this parts locator. Really useful. So usually what people recommend, and I also recommend that, is to start with the components with the lowest profile on the board. So I'm going to start with the smaller resistors, with the diodes, with the ceramic capacitors, and then slowly build up height, I guess. And I'm probably going to put on the large electrolytic capacitors last and the connectors. So that's the way I want to do this. And whenever I come across something interesting, I'm going to pause the montage and tell you about it. But this is going to be more or less one big music video featuring the music by Focus 10. That is also going to be linked in the description. He has a Bandcamp page now where you can also give him some money for providing the music to my channel and to the world. And yeah, I highly encourage doing so because that's so very generous of giving me the opportunity to play Focus 10's music on my channel here. Thanks for that. Check out his Bandcamp if you are interested in the music. You can download for free, or you can give him a small amount of money. You can specify which amount of money you want to give him. And I'm actually using this app, which is just called Resistor, to determine the color codes, because of course the resistors are not labeled and people who actually know their electronics know the color codes by heart. I don't actually, I have to admit, and this is very useful. And I'm also measuring things with my multimeter, so I can be sure that the value is not completely off. So these resistor packs, there are several of these, they actually have a marking like this stripe or a dot for one pin, and that's also marked on the board. So the marked pin goes here in the square field basically, so you can't really get that wrong. So I also soldered in these rectifier diodes, which are just 1N4001 standard. These are really standard parts. I took them from my parts bin. There are, however, some Zener diodes and such. I'm at CR1, which is a 2.7 volts Zener diode, and I don't have any of those in stock. I have a couple of Zener diodes, but not that particular voltage. So I'm just going to salvage it from my spares board, which is a slightly older revision of the board, 250425, but it's very similar. In fact, they mostly changed the 8 RAM chips to only 2 bigger capacity RAM chips. So I think this is the right part. I'm just going to desolder it from here and solder it onto the new board. It's a bit of cheating, I know, but some parts I'm just going to salvage because this board is a spares board that's beyond repair, which has a lot of broken traces on the RAM and elsewhere. So I think I'm going to get away with this and still call it a build with mostly new parts. Diodes have a polarity. That's something worth pointing out, I guess. They have a marking on the negative side, and it's also, there's a stripe usually. It's also marked on the board, so again, pretty easy to see. So these resistor packs have the values printed on them, but they're not very clear actually if you haven't done this before. This one says 332. That means it's a 3.3K ohms resistor pack. It also has the designator for the pin 1. 330, as in this case, actually means 33 ohms. So you're basically adding the number of zeros to the number that the last digit is. That's how these things work. So I actually have a 6.8 volts Zener in my little stash of Zener diodes here. So I can populate CR2 with a new component. Yay! Always good to have a magnifier ready, especially for these little actual ceramic capacitors. And they have designators printed on them, but they are teeny tiny. So there's 1.1 microfarad, that's 104, the label. 51 picofarad is 510. 390 picofarad is 391. So now we have a lot of these 0.1 microfarad, which is 104. 29 of them. So that's going to be fun. And yeah, it's literally going to be fun because I like soldering. And thankfully they are all in this one bag. And I'm just bending the legs sideways so they don't fall out, which works really well for me for these small components. And this is where the PCB locator comes in very handy, although it looks a bit like Las Vegas at night at the moment. So as you've probably seen in the time lapse, I had this populated with this one, which is apparently the wrong capacitor, I think. Yeah, otherwise it went pretty well so far. So we don't have L5, I think we have to desolder this from here, which is an inductor. It's just a coil, 1.2 microhenry. And there's also another one. We have to salvage those, I think. I'm also going to have to salvage several other parts. This inductor here, which is L4, which is a 4-pin inductor, actually filtering the voltages coming in after the jack here, the socket. And the crystal we are also going to have to salvage. And I think I also need to salvage this transistor, some of the other transistors I might not have in stock as well. I'm just going to do that now, I think, because I already have the desoldering station fired up. These are all components you can still get, I think, or equivalent components for these, but I'm just going to salvage them because I don't have them in stock. And I have this board to salvage them from. Okay, so this is where this goes, because it's a filter for the input. It's actually a film capacitor. I mistakenly put it in here. Couple of standard 1N4148 diodes. These are the most common diodes you can find. So I have plenty of those in stock. And again, they have a ring that indicates the negative side. So it's marked on the board as well. The little transistors that you can see, the small black things here, they are just very regular NPN small signal transistors. And there are C945s on this particular board. There are C1815, which they are standard parts, and I thought I had some in my parts bin, but I don't, so I'm just going to salvage them from this board. In this case, C945. They are marked as 2SC1815 in the parts locator, but yeah, these are fine, and they are probably equivalents, but I'm just too lazy to figure out the equivalents and figure out if I have them, so I'm just going to salvage them. These are all parts that are still readily available from various electronics parts sellers. There we go, my little transistors. C15 next to the VIC2 graphics chip is a tantalum capacitor. It's also provided in the kits. And these are actually polarized. So the plus, which is not marked on the board, is facing downwards. And on these, as opposed to electrolytic capacitors and other components, the positive lead is marked. You can maybe see the little plus marking there. And one thing to go by in most cases that you can use is that the longer lead is the positive lead on most components that I bought that I've seen. That's a good indicator. So the positive lead should go facing towards me. The last of the really small components is this trimmer capacitor that's used to make up for slight timing differences, is provided in the kit. So it goes here where CT1 is marked. So I think that's all the really small and flat parts covered. Time to put the sockets in for the ICs. And yeah, they should all be provided in the kit as well. So I'm just going to use these, which are nice turn pin sockets, which I prefer over the leaf sockets. Especially if you have something where you don't change around parts all that often. These have a much tighter grip on the components. These have a little notch on one end, and you should line them up with the notch that is indicated on the silk screen of the board. Although famously Commodore didn't always get these things right, it's a good habit doing that so you know which way around the chip goes in, because that is going to have the pin 1 in the upper left corner in this case. The markings here. Pin 1 is always the upper left. And the pin 1s are actually indicated by square vias on this board as well. That's nice. And the way I do this usually is to tack a bit of solder on 1 or 2 pins on opposing sides so it holds in place, and then solder the other pins, and then solder the pins I tacked completely. This is now holding in place, and I'm soldering all the pins. This is going to be fun. Lots of soldering. And I'm just doing these one by one, I think, because I don't want to miss soldering a pin. Okay, one in, only 1,000 to go. Actually, using sockets has several advantages. One of them being that you don't heat up the actual IC while soldering, because that can sometimes damage them. And you don't risk doing that, you only heat up the socket pins, which are not easily damaged. The other thing, of course, is you can replace and change things around easily without any soldering in the future. So that's a very handy thing. Yay! And that's all the IC sockets in. Things to take care of are making sure that you don't get any solder bridges, which can happen, this pin spacing, and make sure you don't have any stray solder blobs that are anywhere on the board or any little residue of solder. The backside looks messy because there's a lot of flux still. We're going to clean that later. But for now, yeah, this went rather smoothly actually. So I think the next step, and this is actually the first special thing that I do to this that's not like a stock C64, I'm going to populate the voltage regulators, and I'm going to use switching regulators, which I've already tried on a regular C64 in my DC to DC converter conversion, which I'm going to link the video. There's actually two videos. The first video I replaced both of them, and when I replaced the 12 volts one, the SID chip was making kind of strange noises when I turned the machine off. So I don't really want that to happen, but I think as I'm going to use a replacement SID chip, I think that probably can handle the voltages better than the real SID chip. What I think happened is that the 12 volts, they took too long to turn off really, because the DC to DC converters take a lot less power than the linear regulators that are in here in these positions in a real world old school C64. So I'm going to put these in here. These are Recom brand and they are actually labeled as a 78050 1.0. This is the one I'm going to use for the 5V line. I have one of these in my main C64 and works absolutely no problems whatsoever. So this I'm not too worried about. And this is kind of the 12V equivalent R7812 0.5, so this is half an amp and the other one is 1 amp, so they should be equivalents to the original parts. And I actually don't know if this is going to work, but I'm going to try. That's the whole point, I guess. And these also run a lot cooler because they are way more efficient than the original linear regulators, so they don't need a heatsink. And they should produce very little ripple because these are quite expensive actually, good DC to DC converters. I think you could get away with using way cheaper ones. But I kind of want this to be nice. And pin 1 is marked by a little dot. Don't want to reverse these. And we can always replace them with 7805 and 7812 voltage regulators, linear voltage regulators, if it doesn't work. I kind of think it will work. For the bridge rectifier, I'm going to use one that I've used in a number of future-proofing Commodore 64 builds or refurbs. This is a KBPC 610 and yeah, it's way over the top. You could get away with using a much smaller one and the originals are much smaller, but I'm using these because why not? Because these don't perfectly fit the pin spacing. You have to slightly raise them, which is a good idea for air circulation because these run quite warm actually. They are made to be warm, so nothing to worry about there, but a bit of extra air circulation doesn't hurt at all. For all the connectors, I thankfully have the kit from the Run Stop Restore. So I'm just going to use this. And it also includes the fuse holders and the fuse and the power switch. So that's really nifty because these are non-standard parts, or at least some of them, that are not easily found from regular sources. It's really handy to have these all in one place. I think it's a good idea to screw these joystick ports down before soldering with the nuts and bolts that are also provided in the kit. So just so the solder doesn't get cracked if you tighten the screws after soldering. Now for the connectors for the keyboard and the power LED. And then we're almost done. Then the only things that's left to solder on are the electrolytic capacitors. But first, the connectors. And these are just regular 2.54mm spacing pin headers. These are the ones with long pins. So yeah, they fit the connectors. Now for the electrolytic capacitors, and yeah, this is a thing you've seen me doing a number of times on this channel, I suppose. Basically it's just recapping without the re. And the capacitors were provided in the kit actually, but I am going to use my own capacitors because frankly I think they are better brand. For the actual capacitors I am going to use Vishai brand ones because I really like them, and for the radial capacitors, I'm going to use my Panasonic FC series caps that I use all the time and never had any issues with so far. That's just a matter of my personal taste. And I'm using the parts locator because it makes things way easier. Okay, here's the thing that I found actually. C200 is supposed to be a 2.2 microfarad electrolytic capacitor. Actually, they don't have the polarity marked and it doesn't look at all like the footprint of an electrolytic. I think Commodore used an electrolytic in that spot for these boards, but as you can see on this slightly older board, the C200 is a disc ceramic capacitor. So maybe they just used both in different production runs or something like that. Or they decided later about using an electrolytic because it was cheaper, or I don't know, because it worked better. However, I'm going to put an electrolytic in because it is specified both in the parts locator and on the little bags. It's 2.2 microfarad C200. So yeah, I'm just going to use that. So figuring out the negative side of the capacitor is not that difficult. We just set this to continuity testing. And the negative sides should be connected to ground in this specific one. So this side is our negative. And of course the negative is the marked one on these electrolytics. And the long lead is the positive one. Okay, one last thing to solder in is the RF modulator. However, I'm not going to use an RF modulator because who uses analog television anymore? And the RF modulator deteriorates the video signals anyway, so I'm going to use this little board, which is actually made by Copper Dragon, and it's available on GitHub, so you can make your own if you so desire. It's basically the little part in the component mod that I've made a video about that also was designed by Copper Dragon. This is the part replacing the original RF modulator circuitry from that project basically. This should give me the normal video output on the audio-video jack here and not give me an RF output, which I don't need anyway. And this is going to have the best possible signal quality. This was donated by Michael actually, who donated a bunch of things that I'm going to show in some future videos. Just going to find some pin headers to solder this in. This has positions for the long boards and the short boards. This is a long board, so we're going to have to populate these rows facing towards me. There's some solutions for this that you can build or buy pre-made, and you can of course salvage an RF modulator from an actual C64 board. I think the ones for all the long boards should work in this board as well. Now the only thing left to do is do some cleanup work. And I think I actually managed to put the cartridge connector in at an angle. Yeah, let me just quickly make everything look nice so that nobody can tell I'm terrible at soldering. Oh, and what I also have to do, there's actually a little jumper here that determines if this is a PAL or an NTSC machine. There's some little solder bridge points where you can set the specifics of the PAL output. I'm going to have to solder in a wire here. So this jumper here, we need to make a connection between these 2 points. So I'm just using, I think, a capacitor lag probably. If you have an NTSC machine, you obviously leave this jumper open. So cleaning up with some alcohol and a brush, especially on the flip side, because there's a lot of flux residue, of course. It was a lot of soldering. So that should conclude the soldering portion of this build. So it's time to populate the board actually. And thankfully all the logic and RAM is also supplied by the Run-Stop Restore. Martijn sent me the whole range of kits, so we should have no problem populating this. And also it's labeled which logic chip goes where on the board. So let's just do that. I'm just going to put my anti-static wrist strap on for this, because now we are dealing with some more sensitive components, obviously. And there's also the 556 timer chip included in the package here. Usually what you do is to bend the pins inward. I usually do it on the table a bit with new chips, which these are. So they fit into the sockets. NE556 timer. This is just pick and place. So I'll just time lapse you through it basically. Yeah, so far we put the standard logic chips in, which are all readily available still. These are really standard 74 series logic. This is the RAM. This is 4464, two 4464 RAM chips. The first custom chip that Martijn also supplies is this 8701, made by MOS actually, which is responsible for a lot of the timings of the VIC-2. This is a part that actually frequently fails because it gets so much use. I'm not going to use this original chip that Martijn supplied though. I have something else that I want to use. This was made and sent to me by Jeff Bird of the Hey Bird YouTube channel. I'm going to link his channel in the corner here, because you should check that out, definitely. Very nice retro channel and very knowledgeable person. So he made this based on the work of Frank, who's also known as IZ8DWF in the scene, and he also has a YouTube channel that you should check out. He actually developed the circuit for this, and Jeff miniaturized it so that it nearly has the same dimensions as an original chip and fits the Commodore 128 in particular. That was the goal of his endeavors, because he had a C128 that had a bad 8701 timing chip. He wanted something that fits, and he sells these both as kits and pre-assembled on his website. So if you want one of these very elegant replacement 8701 chips, get them from Jeff's website. I'm going to link that below in the video description. So this should fit in here. It does. So for the VIC-2 video chip itself, there's no replacement yet. I think we are pretty close to seeing an actual FPGA implementation of this or some other kind of replacement for this, but there's nothing that's finished. I think several people are working on reverse engineering this chip and are combining their knowledge. Maybe something is going to come out soon, but for now, just going to use an original VIC-2. And Martijn from Run-Stop Restore actually sent me this second box that says surprise. And surprise, I already opened this, of course. It's got a nice card. And it says there are C64 chips in here, so let's have a look. And actually Martijn sent me a full set of C64 chips, so thank you very much for that. This actually includes a PLA replacement that I'm actually going to use. This is the PLAnkton, one of the best PLA replacements available. This was made by Eslapion, or Eslapion, I think it's rather supposed to be pronounced in French, who I also mentioned in my Commodore 16 Saruman RAM expansion video. That's also one of his projects. And actually makes a RAM replacement for the C64 too, but I didn't get that yet. That's a future thing I want to probably put in this C64. I'm going to use the PLAnkton as a PLA replacement. And I'm going to use the original VIC-2. So this is a PLA that goes here. VIC-2 is actually the real-life original VIC-2, revision 3 from 1986. Quite period correct for the original 250466 board. I am going to use this original 6510 processor for now. It says OK on the bottom, that's a good sign, I guess. And I am going to use the CAA chips, which are 6526. There's also no replacement for those yet, but I know there are some people working on those. I am going to use the original ROMs. This should be the basic ROM. Because, of course, you could use EPROMs or more modern flash ROMs or something like that. But I think I have so many of these chips that I want to use these rather. And Martin sent me some more. So probably going to put in a kernel switcher at some point or something like that. So Martin included a Nano SwinSID, which is using a little ARM processor to emulate a SID chip. And I think I want to use this for now. I have something better that I'm going to try later, but for powering this up and initial testing, I'm just going to put this in because it's way less expensive than the other thing I want to try. Plus I have several of these Nano SwinSIDs, so it wouldn't be that bad if it failed. I have to populate the fuse, of course. Just bending the fuse holder a bit, pre-bending it a bit because it was bent quite closely. There we go. Okay, in theory, and if I did nothing horribly wrong, this should now be a functioning Commodore 64. Let's find out. So, yeah, crossing my fingers a lot, because there's a lot of things that could go wrong with this build, of course, because there's a lot of building involved in this. So, yeah, I think I would just want to try to power this on. Now it should have power coming here. And now we flick the switch. Cross your fingers, everybody. And made a ding. And we do get a messed up signal. Did we go too far with the replacements? Or is there something else rotten here? Oh, actually, I think I know what the problem is. We're supposed to ground this little thing. Let me investigate this. And as it turns out, it actually was a really stupid mistake I made. I forgot to add the ground pin here, so I soldered in a botch wire. For now, I'm just going to come up with a better solution. There's actually a hole right below there, and you're supposed to put one more pin header pin there. So I'm just probably going to put a wire in there. For now, this should be grounded, and maybe this fixes the problem with the video output. Okay, this time for real, hopefully. Let's see. Ooh! Okay, that's at least better than what we had before. This at least resembles a Commodore 64 startup screen. Probably time for some troubleshooting. Yeah, it would have been a miracle if this thing worked first try, I guess. Let's figure out what's wrong. Yeah, after putting this through some of my usual troubleshooting paces and using the usual sites I go to, I determined that actually, because it was displaying the same screen no matter what I did, and it didn't start up a cartridge at all, that hinted to the CPU being broken. So I took out the CPU that Martin supplied and put in one of my spare CPUs. And yeah, guess what? It totally works. So I in fact made a C64. That feels pretty good, to be honest. So apart from me forgetting to solder on the ground pin, it wasn't really my mistake. And I did everything right, obviously. So let's put this through some tests and see if it actually fully works. But I'm quite optimistic that it will. Nice. And the little bing you hear is just the SwinSID initializing. That's like a feature of the SwinSID. That test takes a couple of seconds to start up actually, but then it should pass through, I hope. Yeah, it passes all the tests. Nice. Of course, I'm going to do some more tests. So I tried many games and many demos on this. Actually stayed up late to play with this thing, and it seems to just work perfectly fine, which is amazing, of course. And even with the replacement chips, it does work absolutely no problem whatsoever, it seems. And for my testing I have temporarily connected a keyboard. This is just the top half of another C64. Connected the keyboard from that to be able to run stuff and test stuff. And as far as I can see, everything works. I've thrown a lot of stuff at this and a lot of demos that are pretty demanding on the hardware and on timings and such. I ran the Super Saxon cartridge from my Backbit cartridge, which I have, which actually runs the Super Saxon cartridge. The 1541 Ultimate 2 Plus doesn't do that. It actually doesn't run the card. Backbit does that, so one more reason to get a Backbit, I guess. So Super Saxon actually is a good test for the PLA functioning correctly, because many replacement PLAs can't run that correctly and you get like scrambled graphics and such. PLAnkton is known to run that fine because it has the exact timings correct. So if you have an EEPROM replacement PLA or something like that, you might run into issues with the Super Saxon cartridge in particular, which is a good test to figure that stuff out. So one last thing that bothers me. The Nano SwinSID is okay. It actually sounds better than I remembered it to sound. Maybe I got a slightly newer version of the firmware on there or something like that. I don't know. It does sound reasonably good. And it is a very reasonable replacement for a reasonable price. I think these cost like 14 euros. And you can also, of course, make your own. The PCB and everything is free to download. So you can make your own version of this, or expand on it, or whatever you want to do with it. However, I think I have something better. So here's the thing I want to use for this build. And actually I'm in the fortunate and very privileged position to just be able to drop Martijn, who designed this and produces this, an email and telling him about the project, and he just agreed to send me a sample to use for this build of the ARMSID. And the ARMSID is it's basically a similar approach to the Nano SwinSID in that it is based on a little ARM chip, a little microcontroller chip, but it is so much more sophisticated. And actually Martijn put a lot of work in this, and there are regular firmware updates to this, things like that. It's very well built. Yeah, let's take a look. You can actually buy these for 27 euros, which is a steal for what it is, on RetroComp.cz, and I'm going to link that in below as well. Let's check it out. It comes in these ESD safe boxes, and look at the beautiful thing. So the pins are gold plated and things like that, and there's so much attention to detail. Yeah, look at this. It's beautiful. Look at the design. It's so cute. It actually looks like an actual chip if you put it in there. And there's several versions of this. Martijn was kind enough to send me a 2 SID version as well, which has needs 2 sockets in the C64 you put it in, so we can't really put it in this one in this state. Maybe I'm going to put it in here, or maybe I'm just going to make a separate C64 build with a stereo SID and 2 SID sockets. For now, we are going to use this. Yeah, and this is actually pretty special to me because I am a huge fan, in case you didn't know, of the SID chip, the original ones, and especially the old ones, which are even more difficult to emulate, because they have so many flaws that give them the particular sound they have. The newer 8550 SID chips are actually a lot better from a technical point of view. and have a lower bass frequencies. They have a lot more oomph, basically. But I still like the more analog sounding 6851 version, the initial versions of the SID chip. And this supposedly can simulate that sound quite accurately. So yeah, I'm really looking forward to trying this, and that's what we're going to do. And obviously it will be interesting to see if it works at all and fully in this configuration with so many replacement parts. And non-standard power supply and non-standard voltage regulators. Everything's a bit different from a stock C64, so we're going to see. Yeah, this thing rocks. It actually has really tight bass frequencies, which is, I think it's a bit tighter than the original 6851. But that's not a bad thing. You can probably barely hear it through the microphone, but I can tell you this thing sounds really fat. And not as clinical and dead as the Nano SwinSID tends to sound like. This is actually really good. I want to check out some more stuff that I know how it's supposed to sound. This is pretty close to what this sounds on my stock C64 with the old version of the SID chip. And this should actually auto-configure to be to emulate the old version, because it gets the 12 volts supply like the old version of the SID chip. So it can just determine which one it emulates, and this makes this a drop-in replacement for all board revisions. So you can just drop this in your C64 and be safe, and it's just going to auto-configure to the particular SID needed in that machine. That's awesome. That sounds really good. It kind of sounds more bassy than your standard SID, which is not a bad thing at all. Just it feels really powerful. I think it's also louder. Yeah. I used the internal SID player of the 1541 Ultimate cartridge to play some of the stuff I know. This is one that sounds particularly bad on many replacement SIDs. The title track of To Be On Top by Chris Hülsbeck, which uses a lot of samples, which actually work way better on the older SID revisions. Because it utilizes many of the flaws that those have. And this sounds pretty good, actually. It sounds pretty close to the real thing. I'm definitely going to make a separate video going deeper into this and comparing it with different SID revisions. Wanted to do that anyway. So for now, color me impressed. This thing is very good. So, and actually, obviously, I ended up playing with this for several hours, and it seems to work flawlessly from what I can tell from my testing. The ARMSID sounds amazing. The quality from the RF modulator replacement is amazing. The timing chip and the PLA replacement work flawlessly. The voltage regulators actually work flawlessly as well. Probably, I think if we had an original SID in here, we would get the farting noises I made the video about ages ago. Yeah, in this configuration it seems to work and doesn't seem to cause any interference with any of the components. So yeah, one last thing that I can do, because that replacement already exists, is the case. And I actually had this sitting here unopened for quite a while. I got it shortly after the new batch of PixelWizard C64 cases was released. So, what color did I get this time? Let me show you. I thought, because this is such a futuristic build, or kind of futuristic, it's not really futuristic, of course. I got the clear one. I have a thing for clear cases. I put my Amiga 1200 in a clear case, and I'm probably, whenever clear cases are released for other computers, I'm going to get them again. I know it's not everybody's taste, but my taste, I love transparent stuff, probably because I love the electronics and I love to actually see them in there. Ah, look at it. I think it looks pretty darn cool, and it has the old style Commodore logo, and it also has the old style 64 logo, which I think looks just amazing on this one. It's on a like slightly silvery reflective sticker here. I don't know if that's very visible on camera. I think this looks really good. Let's put the board in there, I guess. Yeah, and it is a tight fit, but it should work. Not going to use the original screws because they are crap, frankly. I have some fitting screws. They are just, I think they are the standard size you find on many things. And even the ones that I salvaged from DVD players and such are better than the ones supplied, actually. And of course it's difficult to screw them in, just because this case is new, so there are no drilled threads. Yeah, that went in rather nicely. I like it. So considering the keyboard and the LED, I'm just going to take them from this machine. Because, yeah, the keyboard, there's actually several things to replace the keyboard. There are new keycaps. There was an Indiegogo campaign that started ages ago and got delayed quite a bit because, obvious reasons, the pandemic was happening. So for these Commodore 64C cases, you actually need little standoffs where the keyboard actually sits on and gets screwed to. And I know I have some 3D printed ones somewhere, but I can't find them at the moment. So I came up with this workaround, just stole some Lego bricks, and I'm going to put them here temporarily until I can find the proper standoffs. I know I have them. Daniel, aka C64 Customs, gave them to me when he visited me. And I can't find the box of stuff he gave me. It's just a small little treasure trove of things. Yeah, I can't find it, so I came up with this temporary solution to have something. And I think it should work pretty well, actually, because it sits rather tightly still, because it's clipped in here, or it sits in these clips. But yeah, as I said, for now I'm going to use this keyboard. There is a couple of projects, actually. There is the Mac board that actually replaces this whole assembly with an assembly that actually has tactile switches for every single key, and I am going to get one at some point, but it isn't here yet, and I want to kind of finish this build for this video because it was probably long enough. So we're going to have to make our own power LED assembly, and for that I'm going to use this green LED that I salvaged ages ago, I think from an old like VU meter on an amplifier. Usually the bigger piece you can see in here is the cathode, so that's negative, and the smaller piece is the anode, so that's going to be positive. And we have to file this down slightly, because famously, this doesn't quite fit in here. So I think we have to file down the sides a tiny little bit. And I'm just going to use one of my trusty nail files for that. Yeah, this is going to do nicely. So we have to take off some material from the sides and from the other side. This was a standard 5mm width LED, and they don't quite fit, so we have to take a bit off. Okay, just confirming the polarity with the multimeter, with the diode test. This actually should light up, but you probably can't see it in this video light. This has a forward voltage of 1.788 volts, so that should be the correct polarity. So I'm just going to solder on some wires, use some heat shrink to insulate the contacts, and I'm going to crimp on a little connector, which is a connector for a pin header, of course. And lengthwise it's going to go from here to approximately here. So we need a diagonal like this maybe. So on the board, as you can see, is actually a 3-prong connector. And that's because the middle pin is ground, both of the outer pins are positives. So you can have a connector where only 2 of these are populated, and you can put it in both ways. Quite intelligent engineering, Commodore. And I'm just going to make one like that. So 3-pin, 2.54mm pin spacing connector with ground in the center and one connector for the positive, one of the side pins. I like to twist them a bit, just like the original cables. So this is what we want. We have the outer pin, or one of the outer pins, positive, and the center pin should be the ground. That looks good. Okay. And then we put it all together. And hey, I am quite pleased with the results. What do you think? I'm definitely going to open this up again when I find the standoffs. But this looks kind of great, kind of cool. Let's see if the LED actually lights up. And it does. It does light up, but it's a bit dim because these green LEDs take a bit higher voltage than the red ones. So this is an old LED too, so I'm not too sure about that. Maybe I'll put something else in there at some point. But for now, this is a working Commodore 64. Yeah, so much for this video, I think. As I said, this is going to be a work in progress for some time, but I'm quite pleased with how it turned out so far. Definitely going to put a brighter LED in, that's a bit dim. But yeah, some other things I want to do is to put a completely new keyboard into this. Probably some kind of kernel switcher. I haven't quite decided what to do there yet. If you know of any modern replacement parts that I haven't tried and you want me to try, or if you have developed a replacement part that I didn't know of, please let me know in the comments. Also let me know any other ideas you might have. If you like this stuff, please give it a thumbs up or even subscribe to this channel. There's plenty more videos coming about this, and I'm also going to build some of the other replacement boards that are available out there for purchase or for free. Yeah, and before I forget, extra special thanks go out to everybody who supports me on the YouTube memberships page or on Patreon or with little donations. Thanks to everybody who donated parts for this. I still have a lot of C64 parts, but as I said, I'm going to build at least one more C64 board completely from scratch, so they are going to find a good use, and if they are not used in one of these builds, they are going to be used to repair broken C64s, so they are in good hands with me, I hope. Thanks everybody, and yeah, hope to see you again on this channel. I'm Jan Beta, thanks for watching, see you next time, bye!